name is Eleanor, and I'm the Education Manager at Benjamin Franklin House. Thank you so much for joining for this week's virtual science class. We're going to be looking at Ben Franklin and what he wrote about the Northern Lights. Now, we're really looking forward to you participating in the class, whether that be by asking or answering questions or leaving comments or feedback. If you're tuning in live, there are two ways that you can do this. So the first way is using your raise hand button. And to get this up, you need to either tap your screen or click it with your mouse. And then you should get a banner at the bottom of your screen, which has different icons. And one is a hand. And if you press that, then Caitlin, who you should be able to see as well, who also works at Benjamin Franklin House, she will be able to unmute your microphone, and then you can ask your question over the audio. And I'll do my best to answer. The second way that you can ask a question live is by using your Q&A button. So once again, if you tap your screen or click your mouse, then that banner should come up and you should see one button that has two speech bubbles. And if you click this, then you can write a question in the Q&A. We are also recording today's lesson, so if you're watching this on YouTube, then you can always leave a question in the comments, or you can get in touch via email by sending it to education@benjaminfranklinhouse.org, and we'd always love to hear feedback or see photos of you doing the activities at home as well. So today's subject is the Northern Lights, and that's what you can see in the image, which you should be able to see on your screen on the left, those beautiful colours in the sky. And maybe you've heard of the Northern Lights before. You might have seen pictures or videos, or maybe even seen them in person. Now, as well as being called the Northern Lights, they sometimes get called the Aurora Borealis. And it was another, this is Latin words which mean dawn of the north. And that's because we mainly see the Northern Lights in the north, near the North Pole. There are actually also some lights that happen in the sky by the South Pole as well, and we'll talk a bit more about that later. Now, it was another famous scientist called Galileo who originally called the Northern Lights the Aurora Borealis. And he was an Italian scientist who lived a couple of hundred years before Franklin, and he was very famous. I wonder if anyone's heard about Galileo before, and if anyone might know what kind of scientist he was, or any of the things that he was most famous for. I wonder if anyone's heard of him. If anyone would like to raise their hand or write a comment in the Q&A box.
We have a raised hand from Jessica.
Hi, Jessica.
Hi. My guess is that he studied the sky.
Excellent, exactly. He did study the sky. So he's what we call an astronomer. So that's the type of scientist who studies the sky. And he's probably most famous for writing about, he noticed that there were craters on our moon that orbits around the planet Earth, and also that Jupiter, one of the big planets, had moons orbiting it as well. And also he was famous for saying that the sun was at the center of our solar system, and that all the planets rotated around it, because before that people thought that the Earth, where we live, is at the center of the solar system. So he actually got in trouble for thinking that. So that was before Benjamin Franklin. But Benjamin Franklin did come to be very interested in the Northern Lights as well, and he mainly observed them when he was on these boat trips that he used to make all the time, mainly across the big Atlantic Ocean when he was traveling from America to Europe and back again. And if you were able to tune in to our class last week, which was all about the Gulf Stream, then we spoke a bit more about that. But I wonder if anyone knows what countries he was visiting in Europe when he made those boat journeys. Does anyone know where he was coming to spend quite a few years actually in Europe when he left America?
London and Paris have been guesses.
Fantastic, you're exactly right. He lived in both those places. So he actually made 8 journeys across the Atlantic, because he came to London 3 separate times and went back. And then he went to France as well, and then went back as well. And he lived in Paris when he was in France. Exactly. And so that's why we have a Benjamin Franklin house in London. And this is, you can see a little drawing of Benjamin Franklin house on the top right of your screen. And we do hope that you might be able to come and visit us one day if you haven't already, or come back even if you have visited us in the past. So Ben Franklin spent a lot of time on these boats crossing the ocean or in the sea, and this gave him lots of time to look at the sky and think about the science behind things like the Northern Lights. And on the bottom of the screen, you can see some words that come from a letter that Benjamin Franklin wrote. And here, this is during his second time living in London, when he was at the house. And he writes about how he saw the aurora and how it was really bright and vivid, just like the picture we can see on the screen today. So let's find out a bit more about what Benjamin Franklin wrote down about the Northern Lights. So I've mentioned these long boat journeys he made, and on the left of your screen now, you should be able to see an illustration of this. So this picture is showing Ben Franklin on a sailing ship when he was coming over to Europe, that final time when he was going to live in Paris in France. And at this time, Ben Franklin was 70 years old, and you can see in the picture he's got his cane, he's got his white hair and his glasses. But even then, he was doing lots of really important things for science and also for diplomacy. He was a politician too. Now, on the right-hand side of the screen, you can see a paper that Ben Franklin published about the Northern Lights, and he did this when he was living in France. So the writing you can see, that's Ben Franklin's real writing, and the document, you can now see it at the Library of Congress, which is in Washington, D.C. in the States. And because he was living in France, he wrote it originally in English, but then actually wrote it also in French so that the scientists in France could read about his ideas. So they did lots of different things, even in different languages, Ben Franklin. So what did he think about the Northern Lights? How did he think they worked? So he thought that the shifting lights that you could see near the North Pole were happening because there was this concentration of electrical charge at the poles of the Earth, so the North and the South. And remember, Ben Franklin is probably most well known for his experiments into electricity, his kite and key experiment, his lightning rod, and things like that. So he's very interested in electricity. And he thought that electrical charge at the poles was being intensified by the snow that you get there, because it's very cold, and all the moisture in the air. And he thought that this kind of overcharging that was happening was causing those electrical illuminations in the air. So Franklin wasn't fully right. He was right to think that the Northern Lights were happening because of the forces that happen around the poles, but it wasn't until about over 100 years later that scientists really fully understood how they work, and that was with the discoveries of a Norwegian scientist called Christian Birkeland. So we'll come back on to what modern scientists think in a moment, but I wonder if you can guess what Ben Franklin would have used to help him make those observations of the Northern Lights. And he did think about other things happening in space as well. What kind of instrument might he have used? Galileo would have used one of these, and modern astronomers today still use them, but they can use much more powerful ones. I wonder if someone's got an idea.
We have a raised hand from Irene.
Hi, Irene.
Hi, I think he used a telescope because they weren't very complicated to use, and they were around in those times, and it will be very, very hard to study the sky properly without one, because it's hard to see the sky very well with the naked eye.
Yeah, exactly. Really well explained. Thank you. He would have used a telescope, and we're going to be making our own model telescope at the end of the class. But before then, I'm going to show you one of the telescopes that Franklin actually owned. So on the screen now, on the left, you should be able to see a picture of one of Franklin's telescopes. And he actually was given this during that time he was living in France by a French scientist called Alexis Rochon. And this one you can see still today, and it's on display at Monticello, which is the house where Thomas Jefferson used to live. And Thomas Jefferson was a great friend of Ben Franklin's. He was another American. I wonder if anyone knows who he is, or why Ben Franklin might have been friends with him, what they might have worked together on. Has anyone heard of Thomas Jefferson?
We have a raised hand from Jessica.
Hi, Jessica.
My guess is that they both really like science.
They did, absolutely. So they both really like science. Actually, Thomas Jefferson was with Franklin in Paris for some of the time he was there, and he saw the French scientist Rochon demonstrate the telescope. And they were also friends because they were both politicians too. And like Ben Franklin, Thomas Jefferson was one of the founding fathers of the United States. So as well as being in Paris because they were scientists and they were really interested in all these new discoveries, they were also there as politicians, and they were trying to get the French to help them to win the War of Independence, which is when America broke away from England and became its own independent country. So they were both very important in that process. But so how do telescopes work then? We've got some diagrams on the right-hand side of the screen to help us think about this. And if you were able to tune into our class on Ben Franklin's bifocals, we talked a lot about light and how that helps us to see. If you did miss any of our classes, you can always go back and watch them. They're on our website, www.benjaminfranklinhouse.org, and there's links to all the classes we've done so far to recordings of them on our education page. So let's think about how they work. Now, light travels in straight lines, and it's reflected off objects into our eyes. But at each end of a telescope, there is a lens made out of glass. Now, I wonder if anyone knows what happens to light when it travels through something that's transparent. So another material that's not the air, that's transparent, so something like water or glass. Does anyone know what happens to the light?
We have a raised hand from Ling.
Hello. Hello?
Looks like they're not talking. But Marcus says it reflects.
It's close to reflecting. It's something called refraction, which is when the light bends. So light of other objects, it reflects off, and when it goes through transparent objects, it is refracted and bends. So that's what happens in a telescope. So hopefully you can see on the diagram there's two lenses. So the one at the end of the telescope, that is a lens which is convex. So that means it kind of bulges outwards. And on the top diagram, that's where there's a letter L. And when the lens is convex, that means it focuses the light to a focal point, and then the lens that's by our eye, by the eyepiece, that one's going to be concave, which means it kind of dips inwards, and that has the effect of then spreading the light over our eyeball, especially at the back of the eyeball, the part called the retina, and that's what sends signals to our brain to let us know what we're seeing. And that process magnifies the image and makes us think that we can see it much more, it's a much bigger image. So that's how the telescope works. And now we've thought about what Ben Franklin discovered and also how he did it. We're going to come a bit more into the present day and think about what modern scientists are discovering about the Northern Lights. So I'm going to start by showing you a quick video, because really to get the true effect of the Northern Lights, we need to see them in motion. So this comes from NASA, so the National Aeronautics Space Administration in America. And it was taken, this footage for the video was taken in space. So part of the Earth Observations Facility and Earth Science and Remote Sensing Unit. So we're just going to watch the video and see the Northern Lights happening above the Earth, and then try and explain a bit more about how they work. Okay, so I hope you enjoyed that, and I do recommend going and looking at some other videos of the Northern Lights because they really are beautiful. So I've got some more images from NASA and elsewhere now that I'm going to show you to try and help explain what's really happening with the Northern Lights. So Ben Franklin was starting to understand. He knew it had something to do with the North and South Pole, but modern scientists have got a lot further with their understanding. So there's lots of pictures on the screen now. I wonder if anyone can tell me what the pictures on the left-hand side, what's that big orangey yellow object we're thinking about space today? Hello?
It looks like the microphone is not working for this, but I'll call on somebody else. So Jakob and Yassine say the sun.
Absolutely, and I wonder if anyone can explain, it is the sun, and I wonder if anyone can explain what the sun is in our solar system. Is it another planet like Earth, or is it different? What's it a type of?
Chen says it's a star.
Exactly, it's a star, like those little twinkly ones that you can see when it's nighttime, but this one's a lot closer to us, and it's right at the center of our solar system. And like I said earlier, our planets orbit around it, and it's really vital to life on Earth because that's where we get all our heat and our light from as well. So now, as I said, the Earth orbits around it, and that's what we can see in the second picture at the top. So we've got a picture of the Earth, and it's almost like it's been cut open so we can see what's inside it. Now, I wonder if anyone knows what's right at the center of the Earth, and that's what's shown by the kind of orange part of this diagram. Does anyone know what that is, right at the center of the Earth?
Somebody said the core, the VSS?
Yeah, the core. And do you know what the core is made from? What's in the core?
I'm gonna call on Jessica.
Hi, Jessica.
Is it lava? Is it made out of lava?
It's like lava, yeah. It's a molten iron. So iron is a type of metal, and it's really, really hot melted iron. And so the core, that molten iron, is what gives the Earth its magnetic field. And this is what is in the diagram just below that. So the other picture of the Earth, where you've got the lines like this, that's showing the magnetic field around the Earth. So just like a magnet, the Earth has a north pole and a south pole, and there's this magnetic field around it. So on Earth, and we're going to be talking more about this next week, the different states of matter, most materials are either solids, liquids, or gases. But the sun is so hot that it's actually a fourth state of matter, which is called plasma. And because it's so hot, all the tiny particles which make up the sun have a lot of energy, and some of them are able to break away from the sun, and then they come racing really, really quickly towards Earth. And we call this the solar wind. So in the pictures on the left, this is the kind of the bits that are coming off the sun that we can see. So it races towards the Earth, and the picture at the bottom on the left, this is an illustration of what happens when there's a really strong solar wind. So it's not quite to scale. The sun is over 1 million times the size of the Earth, and there's also some planets in between the sun and the Earth, but just to show you what happens, so that the wind comes towards the Earth, and then the Earth is mostly protected by its magnetic field. But some of these particles in the solar winds are able to enter the Earth's atmosphere at the poles of the Earth. So so those places where the magnetic field is at its weakest, so at the poles. So some of those particles get into the atmosphere, and when they do, they come into contact with the gases that make up the air, so particularly oxygen and hydrogen. So when the particles connect with these gases, then they give them lots and lots of energy, which they can't quite contain, and so they release that energy in these light particles, which are called photons, and that's what creates that amazing effect of the northern lights. So we saw in the video before some greenish yellow northern lights, but they can be different colors depending on how high or low they are in the sky. So when oxygen is lower down, it's going to be greeny yellowy. When it's higher up, it gives off a kind of reddish purple color, like the photo you can see on the top right of the screen. And then when the photons are given off from nitrogen, that tends to give off a more bluish color, like the photo on the bottom right of the screen. Okay, so that's what scientists know now about how the Northern Lights work. Does anyone have any questions before I show you how to make this model telescope?
We have a raised hand from Irene.
Yes. Hi, Irene.
Oh, looks like she took down her hand.
Hello.
Hello. I thought the Earth's core was made of iron and nickel.
Right, so there are other things in the core as well, but the main material is iron. Thank you so much for sharing that. Is that Zach?
Yeah.
Hi. Oh, thank you so much for joining our class.
Hi, Emma.
Hi. Brilliant. Yes, thank you for adding that. So there are other materials in the core as well. The main one is iron. Fantastic. Thank you so much for sharing. Okay, so I'm going to take down my presentation now so I can show you how to make this model telescope. So we're going to make this retractable model telescope so it can get shorter or longer. Now, I always try and make sure that our activities are made with things that you can get just around the house. So it really is a model telescope, and it will just help you to kind of focus in on things far away. But if you did want to make it into more of a functioning telescope that will magnify things, it is possible to, on the internet, buy really small lenses that you could attach to the end. So remember, you'd need a convex end lens at this end, and a concave lens at the eyepiece end. Now, so this is the finished product, and I'm going to show you how we're going to get there. So first of all, let's think about what we'll need. So we would need some cardboard tubes. Now, ideally, you would have one kind of kitchen roll size cardboard tube and one kind of toilet roll size cardboard tube. I only had the toilet roll size. So what I'm going to do is I'm going to stick the two smaller ones together and then have the smaller one as well. So the tubes, and we're also going to need a split pin. So one of these pins that you can break apart like this, a split pin. We're also going to need either a ruler, or I actually don't have a ruler, so I've got a tape measure instead that I can measure with, and also some scissors and some tape. So the very first thing I'm going to do, because I've only got these smaller tubes, is I'm going to use the tape to stick two of them together. But you would be able to skip this step if you had that longer tube from inside the kitchen roll. So I take my tape. Now, you might have noticed that my telescope was decorated. So you might want to do that very first of all to make sure you've got a really lovely telescope. Just to save time, I haven't done the painting on this one. I'm just going to show you how to put it together, but you might want to add some decoration. So with the one I showed you before, I started by painting it, and then I used a pen to draw on the stars, but you could also decorate it with felt tip pens or stickers even as well. Okay, so now I've got my longer tube. Now, the smaller tube, we want to be able to fit inside this. So the way we're going to do that is I'm going to cut along the tube. And we're going to just stick it back together with the tape, but make it a little bit smaller. And I'm going to test it inside the tube to make sure it's a bit smaller, but not too small. So we want it to be able to move up and down inside the tube. So I'm going to stick it back together, but make it a little bit smaller. So using my tape. Okay. So my tube is now smaller. I've got the tape sticking it back together. And the next thing we're going to need to do is we're going to need to cut a hole into the smaller tape, and this is what is going to help the telescope become retractable, so move up and down. So this is where the tape measure or the ruler comes in. So we're going to want to measure in about 1 centimetre from the bottom and 1 centimetre from the top, and then we want our hole to be about 0.5 centimetre wide. So it's going to be like a long thin rectangle, the hole that we cut. And if you haven't got a tape measure or a ruler, you could do it kind of approximately, but I'm going to use my tape measure. And you might want to use a pen or a pencil to mark on your measurements. Okay, so hopefully you can see it's like a long thin rectangle, so about 1 centimetre from each end and then about 0.5 centimetre wide. So I'm going to cut that out now using my scissors. Now you have to be a bit careful cutting through initially, just make sure you do it carefully. Okay, so now I've cut my hole, and this is where the split pin is going to go, but we also need a small hole at the top of this tube. So about 1 centimetre in from the top of this tube, I'm going to make a hole, and you can do that either with your scissors or with a sharp pen or pencil. Okay. So then we put the smaller tube inside. We stick the split pin through the hole and through the hole you cut in the small tube, and then you need to spread the end of the split pin. So inside the tube, you are opening up the ends like this. Okay, and then you should be able to move your telescope up and down. So we have our model telescope, and as I said, you might want to decorate yours. It's probably easier to do that before you construct it. And if you want to make it into a really working telescope, it is possible to buy some lenses that you could add to it to make your very own working magnifying telescope. Thank you so much for joining us for today's class. I hope you enjoyed it, and we really hope you'll be able to join us again next week. We're going to be looking at Ben Franklin and storm clouds next week and thinking about the science topic states of matter. And as I said, you can always watch old classes that happened before on our website, and always send us an email to education@benjaminfranklinhouse.org. Thank you so much again for joining us, and hope to see you again next week. Bye, everyone.